talk about gut microbiome, which is the gatekeeper to our health. So it all began with the mapping of the Human Genome Project, which began in 90s and continued up to 2003, when the human genetic sequencing was done. And that led to the interest of the Human Microbiome Sequencing, Human Microbiome Project. And so we discovered a lot of facts. So let us begin with who are we? We are, one second, Okay, so we are super or meta-organisms consisting of an assemblage of different species that form ecological units. So we are super organisms. The human genes in us is only 25,000, 23,000, and the microbial genes in us is 3 million microbial genes. So we are 99% microbial and only 1% human as far as the genes are concerned. And these genes affect our a lot of function, metabolism, etc. So the microbes that reside in us consist of virus, bacteria, protists, archaea, and fungi. And all together, they are known as microbiota. There are around 100 trillion microbes in us, and which reside all over us, in and around us, on our skin, in all the cavities, like the nasal cavity, respiratory tract, the genitourinary tract, and all the ear canal, etc. And the microbiome is the term that is used for the genetic material present in these microorganisms. So these form the microbiome, and the microbiota is the bacteria that lives on us. But these are used interchangeably most of the time. And then of all these microbes, 95% of the bacteria is located in the gastrointestinal tract. And the major microbes are dominated by 6 phyla, which are Firmicutes, Bacteroidetes, Actinobacteria, Fusobacteria, Virocomicrobia, and Cyanobacteria, among which Firmicutes and Bacteroidetes are the major types. And there are also fungi like Candida, Saccharomyces, Malassezia, Cladosporium, and are included in the gut microbiota, as well as the viruses, phages, archaea, and methanobrevibacteria. So just to make you see the impact, how closely these microbes are with us. So this is a magnified image of the intestine, where on the top right side, you can see the microbes, the trillions of microbes there, colorful. And on the right bottom side, you can see the blue thing, that is a nucleus of the intestinal cells. And the green lining that you see is the mucus secreted by the intestinal cells, the thick, nice mucus, which separates the bacteria from the intestinal cells. So you can see in how close proximity the bacteria are staying with us. And the gut, which extends right from the mouth to the distal part of the colon, is lined by these bacteria. And these bacteria affects how we, in so many ways. So we'll see that. Another thing about this green mucosa is that it is made up of carbohydrate, which is kind of complex carbohydrate. And we will see how this impacts. There was a study done in which the mice were given fiber-rich food, and another set of mouse were given fiber-deficient food, like sugars and refined foods and all those things. And you can see the gut lining, the mucus layer, the green mucus layer, and the blue is the intestinal cells, and the red is the microbiome. So microbiota. So you can see that there's a nice thick lining here of the mucus, in which the mouse which is fed with fiber-rich diet, and the mouse which was fed fiber-deficient diet, the mucus lining is thin, and there are gaps. There is intestinal permeability, leaky gut sort of thing. And in the fiber-rich diet, you can see the yellow thing, that is the cell wall, the fiber from the food. So these bacteria, they feed on this fiber, and so they do not disturb the mucus layer. But here in the fiber deficient, because there is no food material for them, there's no fiber in the diet, it is refined sugars and refined food. So what they do is they start eating the microbes, the mucus layer. So the starving microbiome is like eating your mucus layer and thinning it and making it leaky. Intestinal permeability increases, and the microbes are able to, the macromolecules and antigens and all that are able to leak into the intestinal cells, and that creates an like inflammatory environment. So so fiber is the food for the microbiome, and that is the importance of fiber in the diet. This is another experiment in which a set of germ-free mice, which was given obese microbiome from the obese mouse, and there was a set of germ-free mouse which was given lean microbiome, and then their um, conditions, the environmental conditions, their food, exercise, sleep, everything was same, but it was found that the mouse given obese microbiome turned out to be obese, and the lean microbiome remained lean. So that is the impact on the host, the microbiome. So that microbiome evolves over human lifespan, right from before the child is born, and when the child is born, the first 1,000 days of their life, how was the mode of the delivery, and how was the feeding, how were the infections in the early life, and all these things shapes up your microbiome. And we'll see in detail more in the next slide. So the factors that may affect gut microbiota composition in the gestation period, how was the gestational health? Was there any diabetes, or how was the maternal dietary habits? How much pregnancy weight gain was there? Was there any antibiotic drugs involved in the pregnancy period? How was there probiotic rich food and the hygiene and things like that? And then parturition, how was the mode of the delivery, whether it was a C-section or vaginal, because it's been seen that the children born to cesarean and how they are like more prone to infection, more prone to lifestyle disease later in life. It also depends upon the later life also. Then what is the birth weight, whether the child was given antibiotics, whether there was a hospital stay, an ICU stay, intensive care was involved. And in infancy, of the mode of feeding, whether the baby was breastfed, or the breastfed babies, they have better microbiome, and whether the formula feed was given, and the weaning, what kind of foods were given during weaning, when was the weaning started, so solid food introductions, the siblings, and what was the environment the baby was living in, whether it was a highly sanitized environment or more exposed environment. Then puberty, what were the dietary factors? Because again, when the children reach teenage and all their food choices, a lot of junk foods are because they're able to make independent choices. So they eat a lot of junk food and all that. Then how much of travel, hormonal influences, hygiene, and then again, their living conditions. In the adulthood, again, the diet plays a major role. As you now all are aware now, the importance of fiber, the lifestyle habits, sleep, stress, and was there any disease in the adulthood, drugs, antibiotics, probiotics, the physical activities, exercise. And in the old age, because the diet changes and the lifestyle habit changes, less of socialization, less of going out, and they become more disease, more hospital stay, more drug usage. So all that will impact the microbiome. So you can see in the circles there, in the bricks, colored bricks, diversity, the number of microbiome and the diversity is less during gestation, parturition, infancy, and old age. So these are the vulnerable periods as well, when they are more vulnerable to diseases, infections. And in the adulthood, there is the most diversity and the bacteria is most formed. So the immunity also, when you see that it rises up as you go to the adulthood, and then it comes to a decline, there's immunosenescence of the inflammaging happening. So then it brings us to the two terms, eubiosis and what is dysbiosis. So eubiosis is a state with a higher preponderance of health-promoting microbial species. So health-promoting microbial species like firmicutes and bacteroidetes, they are more dominant than the potentially pathogenic species, which is protobacteria, leading to a healthy state of holobiont. Holobiont meaning the human and the microbiota. So higher microbiome diversity is associated with better health and resilience. There should be more number of, there should be a balance and diversity of the microbiome. Dysbiosis is a state where the health promoting microbial species like firmicutes and bacteria is in imbalance with the harmful microbial species, leading to a disease state. And there is low diversity and variability of microbiota, and this is known as the pathobiome state. So you can see here all those factors, the maternal risk factor, maternal infections, mode of delivery, exposure to antibiotics, feeding regimen, chronic stress, food intolerance, and socioeconomic factors. All that leads to changes in the microbial composition, which affects the gut wall permeability. And there is increased antigen traffic. So like similar thing, what you saw, this is a mucus layer and these are the intestinal cells. And these are the microbiome. They are feeding on the fiber and the mucus layer is nice and healthy and there's no leaky gut. But in the disease state, there is more mucus eating bacteria present and fusobacterium and all that. And there is dysbiosis here. So this leads to inflammation, increased low-grade chronic inflammation. So why this gut microbiome is important to us? Because we're just beginning to appreciate the importance and complexity of the interactions between humans and the microbiomes that live in and around us. And they can produce a lot of these microbiome perturbation is associated with a lot of diseases. The genetic microbiome profiling of each individual is unique, like fingerprinting. Fingerprints are each is for each one of us, it's unique. Same way, the gut microbiome profile is unique at the species and genus level and is influenced by various factors like genetics, diet, environmental conditions, lifestyle, early microbial exposure, and the immune system. And the gut microbiome is not limited to the scope of the gastrointestinal tract. It's not that what happens in the gut stays in the gut, but it affects the peripheral organs, the far off organs also, the liver, kidneys, etc. So the metabolites means the gut feeds on these fiber and they produce some things. They excrete some things, they produce some things which are called as short chain fatty acid, the metabolites, which might affect favorably. The short chain fatty acids affect favorably, but there's some other things. If the pathogenic bacteria is there, they may be secreting some things which are harmful for us. So the scope is not only limited to gastrointestinal tract, but there are bidirectional interactions between the gut microbiome and other organs. And this highlights the concept of the gut organ axis. So there is gut-brain axis. There will be increased gut epithelial barrier integrity and permeability, autism spectrum disorder, Parkinson's disease, amyotrophic lateral sclerosis, schizophrenia, gut liver axis, which affects the availability of short chain fatty acids, gut permeability, bile acid, glucose, and lipid metabolism. And it promotes liver inflammation, liver injury, can lead to cirrhosis, hepatocellular carcinoma. As gut lung axis, increased gut epithelial permeability will also alter the immune response. And there can be chances like allergy, asthma, more impact of COVID-19, lung cancer, gut-heart axis, reduced cardiac function, increased cardiomyopathy and cardiac insufficiency, altered host metabolites and cytokine production, and which will lead to heart failure, atherosclerosis, heart diseases, etc. Gut kidney axis, enterotoxins and uremic toxins enter the kidneys through circulation, leading to inflammation in the renal system. And that can lead to chronic kidney disease and renal cell carcinoma, etc. Factors contributing to overall gut health. So what is a gut healthy? Healthy gut microbiome. It is people also, you cannot say that this is the correct gut microbiome. It's very complex. But there are still certain things like in a healthy microbiome, there is more diversity of the microbiota. Many species, many good species, bifidobacterium, lactobacillus, all this is present. And the microbiota is resilience. They're able to bounce back quickly. If a person falls sick or there's an antibiotic antibiotics are given to them, they are able to quickly bounce back to the normal flora. And they support the immune system. They also aid in digestion and nutrient absorption. And they also gives protection against pathogens by competing on for the resources and producing metabolites which are harmful for the pathogenic bacteria. And there are certain specific bacteria like lactobacillus bifidobacterium. They are more in a healthy microbiome. The microbiome varies among apparently healthy individuals and is influenced by factors such as age, diet, medication, ethnicity, geography, and lifestyle. So the industrialized population, they have lesser diversity because of all the sanitized conditions and the moving away from nature. And whereas the hunter-gatherer population, they have more diversity, more resilient bacteria. The specific diet patterns that are associated with that affect microorganisms are, of course, high fiber diet, because fiber is the diet for the microorganisms, microbes. So more fiber means better gut health. And a plate, as you can see, the more vegetables, more fruits, grains, pulses, nuts and seeds, legumes, all which contain fiber, the plant foods are healthy. Mediterranean diet, which again contains a lot of legumes, pulses, lots of vegetables, green leafy vegetables, etc. Olive oil, these are healthy things. Western diet, which is characterized by high intake, or the diet which contains a lot of processed foods, refined foods, red meat, saturated fats, like which is present in ghee, butter, low intake of fruits, vegetables, and fiber has been linked to a less diverse and less healthy microbiome. So you will find more leaky gut, more intestinal permeability, autoimmune diseases, obesity, and all these things will be more when you have a diet like that. A high-fat diet, particularly one high in saturated fats. So saturated fats are present in, again, ghee, butter, animal fats, coconut oil. So these will negatively impact the diversity and composition of the gut microbiome. A diet high in sugar and refined carbohydrates can also lead to an imbalance in the gut microbiome, favoring the growth of harmful bacteria. So what are the effects of the high fiber diet on microorganism? The high fiber diet, they act as prebiotics, means they give nourishment, promote diversity, they help in the growth of the and diversity of the microbiome. Fiber fermentation. So when they feed on this fiber, when the microbiota feeds on the fiber, they produce short chain fatty acids, which have numerous health benefits. And they also provide energy to the colon cell. They nourish the colon cells, and it promotes a healthy gut environment. Short chain fatty acids also help regulate immune function, and they reduce inflammation in the gut. High fiber diets have been associated with reduced risk of various diseases like type 2 diabetes, cardiovascular diseases, certain types of cancer, obesity. So the lifestyle factors that affect gut health. So dietary fiber intake, of course, it affects the gut health because that's the nourishment for the gut microbiome. Probiotic intake, which usually lead to increased short chain fatty acid production, metabolites of the microbiome, increased antioxidant production, and there is improved lipid metabolism, low gut inflammation, insulin sensitivity is increased. There's reduced risk of some infections. And if there is excessive protein consumption, especially the animal protein, there's altered pH, if there's sugar, refined foods, saturated fat, proton pump inhibitors, antibiotics, all this will affect negatively, and there will be decrease in short chain fatty acid production, increased in trimethylene amino oxide that we'll see in the, there'll be increased lipopolysaccharide production, which is an endotoxin, increased cardiovascular disease risk, gut inflammation, there'll be cognitive decline, insulin resistance is increased, and increased risk of diarrhea. So the favorable things for the lifestyle factors which are favorable are the nutrition, exercise, stress reduction, proper sleep, sunlight exposure, grounding, meditation, social connections. All these have got positive impact on the gut microbiome. And the unfavorable ones are like, again, all those processed foods, animal protein, saturated fat, antibiotics, smoking, alcohol, environmental toxins. So here you can see that this person has got eubiotic bacteria because of the diet, plant-based, plant-forward diet, Mediterranean diet, which is like good metabolites, neurotransmitters are produced, vitamins are like produced. And dysbiotic Western diet, amines, polyamines, and hydrogen sulfide methylphenols. So I spoke about trimethylene oxide. So when when a person consumes animal protein, the bacteria produces these they feed on this and they produce trimethylamine in the gut. And then trimethylamine goes to the liver and they get converted to trimethylene oxide, and which is a inflammatory marker, which is an inflammatory marker, and it leads to chronic kidney disease, atherosclerosis, heart attack, stroke, metabolic syndrome, type 2 diabetes, cancer. All that is increased. There is increases, especially with the things like choline, carnitine, which is present in animal protein. These will lead to TMAO production. It's also been seen that the people who are plant-based, who eat a lot of plant, if they eat animal products, they will have a lesser TMAO because they do not have the TMAO producing bacteria. So if they are given, that TMAO is not produced because they do not have that bacteria. So we'll see how many types of fiber are there. There are two types of fiber: soluble fiber and insoluble fiber. So soluble fiber, it forms a gel. It is soluble in water and forms a gels and helps to lower cholesterol and blood glucose. And it's found in oats, barley, nuts, seed husks, legumes, and some fruits and vegetables. And also psyllium husk, which is also known as isabgol. That's also a very good source of soluble fiber. And insoluble fiber is it's not soluble in water, and it adds bulk to stools, which helps to prevent constipation. It's also found in fruits and vegetables, skin, nuts, seeds, wheat, corn, and whole grains. So how does a high fiber diet lower the risk of all these cardiovascular disease and improve the blood vessel function? Because the soluble fiber, as you saw, that it gels, and the cholesterol is produced in the liver. And from the cholesterol, bile acid production happens. So bile acid, from the cholesterol, bile acid is produced, and bile acid then recycles. But if there is a way where you can bind the bile acid and excrete it out, so again, the bile formation will take some cholesterol, and that's how the mechanism that soluble fiber will bind to cholesterol and will bind to bile acids and reduce the cholesterol. The fiber improves blood vessel function by production of nitric oxide, and this nitric oxide, it reduces inflammation. It dilates and relaxes the blood vessels, so it can lower the systolic and diastolic blood pressure levels. The consumption of fiber-rich foods like whole grains, fruits, vegetables, legumes is also associated with lower risk of heart disease and stroke. Fiber-rich foods are also rich in antioxidants because they are found in plant foods. So they have a lot of antioxidants, anti-inflammatory compounds that can help in reducing oxidative stress and inflammation in blood vessels. High fiber diet also helps maintain healthy weight and reduces the risk of obesity, which is a risk factor for all these cardiovascular diseases, and it can negatively impact blood vessel function. How can it improve insulin sensitivity? High fiber diet can improve insulin sensitivity. It slows down when we eat food. It will slow down the digestion because of the soluble fiber. It's more viscous and the food moves slowly through the digestive tract. And we feel fuller for a longer time, and there is slower release of glucose for absorption into the bloodstream. And these fiber-rich foods are also lower in glycemic index, so they will cause a slower and more gradual rise in blood sugar levels, which can improve insulin sensitivity. High fiber diet also promotes healthy gut microbiome, which has been linked because of these metabolites that they produce and their activity. Insulin sensitivity will increase, and there'll be a reduced risk of type 2 diabetes. So what are the gut dysbiosis symptoms? So like we know, whatever happens in the gut doesn't remain in the gut, but it affects all over. So there can be cramps, constipation, diarrhea, all that can be a sign of dysbiosis, like heartburn, gas, bloating, food allergies, intolerances, insensitivities, inflammation, aching joints, acne, skin rashes, psoriasis. There may be chronic fatigue, difficulty concentrating, anxiety, depression, candida infections, problems with the immune system, irritable bowel syndrome, allergies, asthma, headaches, memory loss, and all these things. So it can affect a number of things. And this is all very malleable also. The gut, you can improve your gut health very quickly also. For some people, it may be quick. For some people, they may have to give time. But the gut microbiome can be changed very quickly. You change your diet, you can change your gut microbiome. It's very quick. So you improve the gut health by including more prebiotic soluble fibers, which are found in all the high fiber foods like vegetables, legumes, whole grains, nuts, green leafy vegetables, seeds, vegetables like onion, garlic, legumes like chickpeas, beans, lentils, whole grains like barley, oats, they all contain a lot of soluble fiber. Nuts like pistachios, cashew, almond, flax seeds, chia seeds. So eat a diverse range of food, not just one or two types, but a lot of, because diversity in the diet leads to diversity in the gut microbiome. The more diverse, the more range of food you eat, the more diversity in the gut bacteria. So it is like encouraged to have a rainbow of vegetables. More colors means more diversity and more vitamins, minerals, phytonutrients, antioxidants in your diet. The diversity of food on your plate can help to lead to a more diverse microbiome, which is an indicator of healthy gut microbiome. So like the plate you see on the right-hand side, half of the plate is fruits and vegetables, 1/4 is nuts and beans and seeds, and whole grains, 1/4 is whole grains. Aim to at least eat 30 different types of plant foods in a week. So 30 different type of plant foods. It's very easy to get when you count herbs, spices, legumes, whole grains. All can be counted as one variety of plant food. So you should aim, and it's easy. It's not very difficult. It's easy when you count and when you include a lot of different. So just don't include only one kind of whole grain or just rice and chapati. But try to include a lot of whole grains, like a lot of millets also can be included. A different kind of pulses should be included because different food, different microbiome. So exercise also improves the gut health. Exercise, we know, does a lot of things, but specifically for microbiome, it increases species diversity. The metabolite producing bacteria is increased. Intestinal barrier is good, and inflammatory status is reduced. Another thing that we have to do is we have to limit ultra-processed food to maintain the gut health. So we have to eat foods that are as close to the natural state. Like an apple, if you break it and if you peel it, that's a processing. If you cook it, if you include it in some foods, it's the processing goes like one step. Rather, just eat the apple as a whole. If you juice it, it's processed. So while almost all foods have had some kind of processing, it's better to eat minimally processed food and also stay away from added sugars, salt. Keep the salt intake low, and the fat also, the diet should be low in fat. Additional emulsifiers, artificial sweeteners, all that will impact your gut health. Drinking water has got a beneficial effect on the gut microbiota. It is seen that there is increased diversity of bacteria in the gut, and it also helps in the constipation. And polyphenols, they also affect positively. The polyphenols are the plant compounds that may beneficially impact the gut microbiome. So foods which are rich in polyphenols are herbs and spices, colorful fruits and vegetables, nuts and seeds, green and black tea, coffee, cocoa, and dark chocolate. So these have got anti-cancer, antibacterial, anti-inflammatory properties, and anti-adipogenic properties. Fermented foods are another thing that we should do. So fiber-rich and fermented foods are the thing that we should do for gut health. Fermented foods have undergone a process in which the sugars are broken down by yeast and bacteria. And the fermented foods include yogurt, kimchi, sauerkraut, kefir, kombucha, tempeh. And while research into fermented foods is limited, the bacteria found in some fermented foods have been linked with digestive health and other benefits. So, like, actually, it's like not these bacteria, they do not take up residence in the gut, but they still lower the inflammatory markers. Because when you see in the experiment, it's been seen, the studies that's been seen that when people were given all the fermented foods, the inflammatory markers were lowered, but there were not the similar kind of bacteria was not seen in the gut, probably because they are not well adapted to the gut. Even though they're producing benefit, they may pass or they may secrete some metabolites, and that's how the inflammatory markers might have reduced. But these bacteria, they do not take up precedence. Even the probiotics like lactobacillus and bifidobacteria, which are more adapted to the human gut, can be found, but other bacteria may not take up precedence in the gut. So other things which you can do is eat slowly, properly chew your food, and gut health for the breastfeeding is important to develop a healthy gut microbiome. Exercise is important. Reducing stress, because stress again will there's a bidirectional thing. Like the things which are produced will affect the mood. When you eat a healthy diet, more serotonin production and more stabilizing effect of the mood and the vagal nerve. So same way, when you're feeling anxious, the vagal nerve will be stimulated and will be having gut function, gut symptoms. So stress reduction is important. Sleep is very important. Not getting enough sleep or sufficient quality of sleep may impact your gut microbiome and may contribute to digestive discomfort. Probiotic supplements. About probiotic supplements, it's best to improve your gut health through food and other lifestyle factors rather than supplements. That is the stand. And there are many nutrients in whole foods that cannot be packaged into a single supplement. So the single supplement may not give you good all the effects, because the food, it is not just one nutrient, but it's a package of, it's the whole food package that brings about the benefits. Nutrients in food also interact with each other in a helpful way, and that cannot be replicated in a pill. And I told you about the concept of like the gut microbiome taking residence in the, um, may not take residence in the gut. Many people are interested in taking probiotic supplements, but if there's good health, it's generally not necessary to take a probiotic supplement for your gut, rather than improve your diet and exercise and sleep, other lifestyle factors. Both the antibiotics, so while antibiotics can sometimes be important and useful, they negatively impact the gut microbiome. Antibiotics kill all the harmful bacteria as well as the useful bacteria. So what are the myths about gut health? There are no miracle cures for good gut health. And there's no scientific evidence that individual foods or any other product will rapidly heal an unbalanced gut microbiome. Also, there is no scientific evidence that colon cleansing improves health or is beneficial. Research into gut health is very, very complex. So even when people say that uh, personalized diet, gut microbiome testing and a personalized diet and all that, so that is not very well studied, and we are nowhere there right now, actually. Better to uh, eat high fiber diet and look into other lifestyle factors, and be careful of non-evidence based information about gut health. So fasting is one thing which affects the gut microbiome positively. One systemic review revealed that maintaining a correct eating time and increasing the fasting period could positively affect the gut microbiome, reduce the gut permeability, and improve health. So these gut bacteria, they have a lifespan of around 20 minutes. So they are like many generations are coming in and going. And they may have one set of bacteria may have a different role, the other set of, so when they are also affected by the circadian rhythm. So the bacteria that you have in the daytime, which is helpful in digesting, absorption, all those things will be different than what you are when you're resting sleep. So that feeding window is important. If you are feeding at the wrong times, it may not affect the gut in a good way. This insight was gained by considering different fasting regimes, like the alternate day fasting, calorie restriction fasting programs, religious fasting, all that. This supports the association of fasting with improved health parameters. There's reduced inflammation, slowing disease progression through changes in the gut microbiota, including upregulation of Akkermansia muciniphallus. So that's another which comes in with calorie restriction, Akkermansia. By Bifidobacterium fragilis, bacteroids, and butyric acid producing lactosporacea. Recent studies show that beneficial effects of fasting on metabolic markers. Lee G. et al. Showed that intermittent fasting promotes white adipose browning. So there's the browning of the tissues, which is related with more fat burning happens. Recent evidence also indicates that intermittent fasting may lead to remodeling and increased taxonomic diversity in the human gut microbiome. So the remodeling can happen in a fasted state. So how to determine whether you have a good health status is a very simple way rather than going for very expensive gut microbiome testing, which is not even validated, is to inspect the stool. So we should aim to be somewhere around 3 to 4. 4 is the ideal one, the number 4. So inspecting this stool will give you a good insight into your gut health. So for few days, it may be like for a week or so, the changes may happen because a person may be traveling or there may be some stress, there may be some hormonal imbalance, menstrual periods, and things like that. That might affect the diet. Sometimes you might have eaten outside, that might affect. So for a week or so, it may be okay, the change. But if the change is for a longer duration of time, like you notice somewhere around 5 or 1 or 2, so you might want to get medical help for that. So there's another thing which is for the people, the FODMAP diet, which FODMAP stands for fructose oligosaccharides, disaccharides, monosaccharides, and polyols. So these are the things which are known to like give discomfort to people who are sensitive. So it can be restricted. There's a special diet so these FODMAPs are like wheat and apple and things like that can be restricted. There's a list of FODMAP foods. These can be restricted for a short period of time. So there is an elimination phase and that lasts for 2 to 6 weeks. And then you reintroduce one by one each and notice your symptoms. And then you can personalize, so you have to do it with the quantity. Sometimes you may be able to tolerate a smaller quantity than a larger quantity, milk and all these things. So it requires a longer period, a lot of patience, a lot of information should be journaled and all these things. So it is the goals of low fat diet challenge phase is to understand specific triggers and reduce food fears. So people who have got very sensitive intestine, they may be very fearful about around certain foods and all that. So they'll be able to understand their triggers and ensure sufficient. So this is not a long-term diet. It's not that you eliminate them forever, but the aim is to reintroduce back with the knowledge of what is troubling you and increase the nutritional adequacy and variety, sustain the reduction, improve quality of life. So this is like an example of a plate which has more diversity, more food, like a rainbow. So on the right-hand side, left-hand side, you see a whole food plant-based diet, which is half plate is colorful fruits and vegetables, pulses and whole grains. Whereas the nutrient poor, calorie dense, like a lot of simple carbohydrate like white rice, and even though legumes are good, but still not much of diversity is there. So it's just a comparison. The future directions. So fecal implantation, the fecal microbiota transplant is the studies done, but it's not yet approved and not yet into the mainstream. But for some things like Clostridium difficile infection, it's been seen that it's 92% efficacy than the traditional antibiotics given. So this also is being studied. So in summary, your genome is not your genes is not your destiny. You can improve your health by improving your microbiome. So eat for your microbes. Eat what they like, means eat more fiber-rich diet, exercise, more movement in nature, more getting out, because more you move out, more diversity. Sunlight has an positive influence on the gut microbiota. Sleeping well, 8 hours of sleep. Socialize more to get more diversity of gut bacteria, reduce stress, and avoid substance abuse, because smoking, alcohol, they all are negatively associated with gut microbiota. Thank you.